Alright, so let's get talking. ACS started logging in, but I didn't know your username and password, so I got you to the next few steps. Yes?
If the X's have a number and the Y doesn't, that's
Pause on a second with that. Okay. Alright. So, the sheets of paper that are on your desk, first I want to address those. I've done, which it even says Unit 2. In the past, I've mentioned that I've changed up the order of my units and things like that to work with Ms. Granberry. We made a decision of how we wanted to reorganize this course. That's why it says Unit 2 on there. Obviously, we're actually in Unit 4, I believe, just on quadratic functions. But this is the check your understandings that I used to use and a place for you to have notes. What I have printed out for you is your own check your understandings. You don't need that. So the first set of pages here, please note, is functions and mathematical representations. So it's just identifying if it's a function or not and what mathematical representation it is. If that's a skill you need to practice, here you go, okay? Remember, what's always on the back side? The solutions, right? That way, if you come in and you have a question about something, AC, just put your username and password. I think it's without the @tcss.net, maybe? Not sure. Try it both ways. But the answers are on the back, so you can check yourself. The solutions. Okay? Can I finish off? Okay. The next page is all about what? Page 2. Y'all can see it. You have a packet. Linear and exponential functions, specifically in which representation? Graphically. So the first couple are writing the equations for linear and exponential from a graph. And then finally, in the spicy, you creating your own graph. So if that was a skill that you have struggled with, there's some good practice for you. Next page. Let's say, Finney.
Linear versus exponential functions tabular.
Alright, so linear and exponential and tables. And finally, just identifying linear, exponential, and quadratic functions. Please note that is actually what we did on Friday, I believe, right? So last Thursday, we developed our understanding of what a quadratic function was. Give me a quick recap, a reminder. How do we know when we have a quadratic as a graph?
2x intercepts, I think.
Okay, they do have 2x intercepts, so not the only ones though.
Isn't it like a 2 and an x one?
Say again.
A 2 and an x one?
So which mathematical representation is that? Algebraic, right? So x squared, algebraic, yep. Now I will point this out just in thinking about that. Is that going to be quadratic then?
No.
Why not? What was it?
I mean, it's still.
It could.
I mean, it still has the 2 as far as.
It does still have a quadratic term, okay? So this is why I brought this up. So this has a quadratic term, but is the square the highest power?
No.
No. So I want to be clear about that. It's when the square is the highest power. Okay? So that would not be a quadratic. That's actually something we're going to go into next unit. That's called a quartic, meaning 4th degree.
What would you call it?
There you go. Okay? Yes, Penny.
If it's 3x4, we just say to the 4th power.
3x to the 4th power. Okay? So, my point is not quadratic. But my question originally was, how do we know when we have a quadratic graphically? Yes, it will have 2x intercepts most of the time, but it doesn't always.
The highest, it has a maximum y, and it's a vertex.
Okay, so there is a vertex getting closer, but I will point this out. Okay, right here.
I mean, it turns into a U.
Yes, parabola, upside down.
Yeah.
This has a maximum. Is that going to be a quadratic?
No.
No, because we have to talk about a what? What did you say?
What?
What term did you use? A parabola, right?
Oh.
If it's not a parabola, it is not quadratic. Okay? So even though that has a maximum, and remember, do all parabolas have maximums?
No.
No. Sometimes they have a minimum when, what do we call that direction?
Concave up.
Concave up. Got remember, concave up like a
Cup.
cup, right? So can I pour water in there and it holds the water in there?
Yeah.
Yep. Concave down is like a crown. So remember, I'm pointing this out because I'm trying to recap some important ideas that might help us today as we move through today's activity. Next, or final detail is this. How do we know when we have a quadratic in a table? This is probably one of the harder things for students, but it is important. So let me create two. Hold on. Bless you. All right, so really quickly, I just want you to talk about it with your group. Is it f of x or g of x that would be quadratic? So just talk with each other, see what you recognize there that might make you think if it's a quadratic or not. So think about f of x versus g of x, and we'll talk about it in just a minute. If you had a question of me, you can ask me now. By the way, how do I have 4 people in this? Gotcha. Which group are you in? You're in 4s?
Yeah.
Did someone have a question for me earlier?
Yeah.
Go quickly.
How you doing?
Just now asking?
It is 17
Did you actually have to, or you just heard Parker and had to go? You can wait until he comes back.
Is that 17?
That's why I said
17.
7, 10, 13, 16,
I
19.
gotta bridge to my
Okay. Do y'all have an idea yet? Y'all talked about it?
What's the equation we get on the board? It had constant rate of change.
That was quadratic. Well, it took 2 to get to a constant additive rate. What are we thinking? F of x or g of x? F of x? Why? Say again.
I'm trying to manage.
What did you press? Log in request.
So you're seeing the symmetry in there? Okay, that's good reasoning. I like
And
it.
then continue.
What are we thinking?
And then log in request.
I think it would be everything.
F of x, what's your reasoning?
I just wanted it to be everything.
No, I should be shaking my head, because you know that's wrong. Okay. Say again. You should, under password. It might, you just got logged in, right? It'll take a second for it to pop up. All right, so I've heard from a couple of students that they're thinking it's f of x, and I want to draw on, Carly, what were you saying? Why did you think f of x was the quadratic? Because you're seeing a line of symmetry in there. Notice if I draw symmetry, which is not a line of symmetry on a table, but there is symmetry around it. That might be pretty good reasoning. Dean, Dalton, Brianna, Finney, any other ideas?
I say F of X.
Now, look again. Does it have 2x intercepts?
Yeah.
No.
If I look right here, does this have 2x intercepts?
No.
No.
It only has 1 right here. It only has 1x intercept. Any ideas? Nothing?
Any ideas for it?
About why f of x might be the quadratic?
Probably because it has two, Wait, can I see the other? I can't see the other one. What did we call it? Mr. Kenny, I can't see the other one.
Okay, so that's again the idea of symmetry. So the negative inputs have the same outputs as the positive inputs, right? Okay, but there's something
You have
else.
like two common differences.
Oh, there's a rate of change,
Yeah,
that thing, right? So first off, I do want to point out, guys, hopefully some of us recognize what this equation is. Does no one recognize that table?
Oh, that's I don't know. That's cute.
If I do 2 cubed, do I get 4?
No,
That's
that's
weird.
that's
weird.
that what I'm saying.
That's squared? If I square a 2, I get 4. If I square a negative 1, I get 1. If I square 0, I get 0. So this should be like, oh, that's, by the way, that's quadratic. It's which quadratic? It was what we studied in Unit 3.
Square.
Which quadratic? Yes, it's a square, but which quadratic? It's a two-word term. First one starts with a P, the second one starts with an F.
Parent function?
Oh, that's a parent function, thank you. We should recognize our parent functions, right?
Yes.
Y equals x squared. I did this intentionally to review that, okay? Guys, y equals x squared. But no, Rihanna is 100% right, and I need y'all to pay attention to this. So KB, our head needs to be up, not in our palm, not looking down. Is KB furrow asleep? Come on, man. So look, if I look at this rate of change, is that constant?
No.
No, that's definitely not constant, right? But if I go from -3 to -1, that's +2. -1 to 1 is +2. 1 to 3 is +2. So if this is constant additive, well, first off, so I'm trying to rework my language to help with a little bit. Notice purple is my rate of change. Am I adding, subtracting, multiplying, or dividing? I'm adding, right? Which, because remember, subtracting is a type of addition. And what type of additive? It's not constant additive, it has to be linear additive. Remember that quadratic function has a linear additive rate of change. Don't forget, like, the idea of symmetry, great, I'm glad you noticed that. X-intercepts, it's a good thing to look at. But if you're going to look at a table and know it's a quadratic, you really only have two options. One is to look at the what?
The X's, the Y's, the constant rate of change.
The linear additive rate.
Linear additive rate of change, or just in general,
The rate of change.
the rate of change. If I have a table, guys, I'm looking at the rate of change.
How do we
Or-
how do we get +2 each time? So,
What's
To
the-
go from -3 to -1 is adding 2.
yeah, I'm saying I see it.
-1 to 1 is adding 2.
I thought
To
you
go from
I thought
1 to 3 is adding 2.
2. I thought it was
No,
just
it's like
-3. I didn't know it was negative.
Yeah, it is -3, but that we treat it like a negative in that case to figure out what the next rate of change is. So I see what your question is. But I will also point out, hey, could I have made a graph to look for a parabola?
Yes.
Could I have made an equation to know it's quadratic?
Yes.
So the real two options are make a new mathematical representation or find the rate of change. That's it, okay? Make a new mathematical representation or find the rate of change. Because if I graph that, you know what I'm going to see on a graph?
Right.
That's exactly right, yeah. So this is why I want you to understand mathematical representations. That's what I started with all the way back in Unit 2. Because here's the thing, you should know this rate of change, and that is part of your proficiency scale. However, can you make a new mathematical representation and approach it that way? 100%. Mathematics has more than one option for the solution path, and I want you to find those. Okay, so really quickly, that was a quick recap of everything we have done. And so today, for the rest of today, we're going to be working on a Desmos activity. And so I need you working within your small group. Say again. Your iPad's going dead. Just pack your charger every day. Every day in the club. Just put it in your backpack.
I packed it, but it's still on my
What are you doing with your backpack? No. All right, listen. Let me get through this intro first. Yes,
I
ma'am.
go to the bathroom.
No.
You dying?
No, I feel like I'm finna throw up.
Yes, definitely go to the bathroom. You throw up, let me know, and we can get you a pass to the nurse. All right. So, features of quadratic functions. That's what we're looking at today, based on the different equations. So we're going to go to a Desmos activity. I'm going to have you work in your small groups. I did want everyone logged in, just in case you weren't already logged in. But I will say this: you're only allowed one iPad per group. So if your iPad is dying, okay, if your iPad is dying, then leave it charging or put it up. But decide right now who in your group is going to keep their iPad out. So choose right now who in their group is going to keep their iPad out. Okay. All right. 8, y'all decided? Okay. All right. Pencil sharpener in the back. Hold on a second. All right. So please remember, this is what we did on the last Thursday, Friday, is identifying a quadratic function in a table, a graph, and an equation, and identifying all features of a quadratic function in a graph. So what are the features that I'm talking about in a graph?
Line of symmetry.
Line of symmetry,
Vertex.
vertex,
Y-intercept.
y-intercept, x-intercept.
X.
Yeah.
Remember, the maximum of the min will be a vertex depending
It's
on
something
the
that
what.
starts with a C.
It is something that starts with
concavity.
concavity, right? So, good job on remembering to start with a C. So, yeah, those are the features I'm talking about. So here's the thing. If I look at a graph, okay, I should be able to see all those features pretty easily. But you're in an algebra class, which means we now need to start to figure out how do I know those things just from the algebraic representation, aka the equation. And so we're going to connect the graphical and the algebraic today in this Desmos activity. So, the first part of that is identifying each form of a quadratic equation. I'm going to give you direct instruction on that. Like, I'm going to tell you what they are from the beginning, but you are going to have to take the time to memorize your vertex form of a quadratic, your factored form of a quadratic, and your standard form. The biggest thing I will say is, you will need to take time. What I personally do when I need to memorize something like this is, I write it out. Not forever at one sitting, but I might write it out 4 or 5 times. Day one, and then check my equation, see if I wrote it correctly. And I'm going to make sure that I study and I know what each of the letters mean, and we're going to break those things down today. Okay? But you need to take the time to memorize these equations. If you haven't done that with linear and exponential, you should probably do that. Like, if you just write out y equals mx plus b, hey, m is my slope, my constant additive rate of change, and b is my y-intercept, that will help you remember it. Some people are better with flashcards. You could do that. Someone can make a Quizlet for the class. I don't care, but you've got to be able to know those different forms. Now we're looking at quadratics. And so what our goal is to get good enough at identifying the key features from the equation that we can graph the quadratic functions by hand. You don't have to have a perfect graph, but you need to highlight the key features, okay? And so that's what we're going to start with. We are going to build into going from a factored form to a standard form. I'll show you how to do that later. And creating 2 variable equations in vertex and factored form, and then the idea of roots and zeros. This is going to set us up for the second half of this unit that is all about how we solve a quadratic equation. You might remember from last year, I imagine everybody had experience with their Algebra 1 teacher getting them to factor a quadratic. So we went from standard form to a factored form, and then we solved the equations. Maybe you remember the quadratic formula or completing the square. Those terms don't even sound familiar?
They do.
Okay, they at least sound familiar, even if we don't remember it, okay? So we'll be practicing that today. Okay, so here's the Desmos activity. All right? So I'm going to go ahead and point this out.
Did you puke?
Okay, so, whoops, that's not what I want. So, that's what I want. Alright, so first things first, here are the 3 different forms of a quadratic function or a quadratic equation. This one up here at the top, okay?
You know that one.
You know that one? What's that one called? You've seen that one before, right? Yeah. So here's the thing, that we've seen that a times x minus h squared plus k when we were doing what? Transformations of parent functions, okay? But this specific equation has a name, okay? This is known as the vertex form.
Wait, the third one I know. Yeah, I remember.
What's the third one?
I don't know, but I remember the one.
I kind of remember that too.
Okay. Okay, so I want to break this down, and I'm just going to ask for predictions. Anybody have a guess what feature of the parabola I might be able to see in the vertex form of a quadratic like that? So like think about my features. They're line of symmetry, vertex, x-intercepts, y-intercepts, and concavity. Any guesses which feature of a parabola I should be able to see right away in that equation?
The A and K.
The what?
X-intercept, Y-intercept.
Why do you think x-intercept and y-intercept?
You can already have the H and K.
Okay, so you're thinking x and y intercepts, okay? That's the theory. Any other predictions in the vertex form?
No.
Okay. All right. So we'll talk about that naming convention later because you do need to understand where the name is coming from. Okay, this bottom one down here,
You factor.
it is factored, so we call it the
Factored form?
factored form. Yeah. That's actually what we're going to do second. what do you mean factored? Because I want to break this down. I need you to understand this. AC, I'm going to try to help you understand this language real quick. If you could wake up for me. KB, same thing. Trying to help you understand the background language, why this is called the thing it is.
I think the X, like if it's okay.
Okay.
If the X is 2, you gotta get factors of 2. And I think it's the highest one. It's either the highest or the lowest. I don't know which one.
Okay, let me ask you a different question. Hey, can anybody give me factors of the number 30?
6.
6 and what?
5.
Okay, so 6 times 5. Any other factors?
2. 1.
2. Well, what would I need multiplied by 2?
18. 2 plus 6, 18. What? I just do it. I'm like,
Oh.
2 times. Thank you. 15.
yeah.
Come on, there's another really big one that we're missing. We'll get to that one in a second. Come on, guys.
What do you
30.
do 30 times 1?
Huh?
30 times 1.
Okay, I wasn't thinking 30 times 1. There's another big one.
30 times.
3 times 10?
Thank you. Usually that's the one that like people think first.
No.
I might have missed it. But so these are all different factors. These are known as the prime factors, 2 times 3 times 5. But we don't have to worry about that a ton. But why did you say that those were factors?
And 2 times.
Okay, so factors are something that we multiply to get a product, right? Okay, I want y'all to look at this form again. What are we literally doing? We're multiplying factors, right? In mathematics, we're not trying to trick you. There's a name, there's a reason there's that name. You do have to learn it, but understand, like, it's called a factored form because what are we doing? We are multiplying factors. We're multiplying factors, that's it. That's why we call it a factored form, okay? And then standard form is this middle one here, ax squared plus bx plus c. That's called standard form because that is the general standard form for all polynomials, where you start at the highest power and you work your way down, right? So literally it's what is standard. I'm not trying to trick you. But we need to start to learn those different equations. So you're going to see those terms pop up. That's why I'm talking through them right now. What I need you to do at this point, can I do this? Yeah, I can. So when you look at this equation right here, what form do you have on slide 2?
It's
the
Oh.
graph's the
You got a
parabola.
vertex form.
You got the vertex form. A times x minus h squared plus k. That's my vertex form. Pay attention to the instructions at the top. Okay? So what are you doing on slide 2? You're just...
Adjust the value from the vertex form of the quadratic equation function and observe what happens to the graph.
Okay, so the question is essentially, how does A affect the graph? Now, well, it says affects the parabola. So what I want to point out here is, you're going to see a connection to a transformation that you have done. Okay, so let me say that again. You're going to see a connection to a transformation you have done. But what I want you to think about is what feature of the parabola is it changing? Is A changing the vertex? Is A changing the concavity? Is A changing the line of symmetry? What is A changing about that parabola? So you're going to take the slider here for A, and you're going to slide it. So think through those, what your conjecture about A is. When you have a conjecture, any guesses what I want you to do?
Write it down.
Where am I going to ask you to write it?
Vertical surface.
Yeah, I want you to write on a vertical surface. One thing I want to remind you is, knowledge is mobile. You all need to learn this. It's not about one person figuring out from over another. Look around the room. See what help you can get from others. Please note, when you have a conjecture, though, go to the next slide, because I will have a specific question that I want you to think about. Okay? When you are done with this slide, move on to the next slide, and notice what are we looking at in slide, I think this is 4 maybe? Okay.
H and K.
H and K, right, in the vertex form, okay? So, again, what feature is it not just changing, but what is it controlling? Is that H and K directly connected to the x-intercepts, or is it directly connected to the vertex, or is it directly connected to blank, right? So what is it controlling? Just come up with conjectures. When you have conjectures, move to the next slide and answer it, okay? So, what are your questions about these instructions?
Nothing so far.
Nothing so far, okay? And again, I do want to remind you, do you have to be right? No, you don't have to be right. Because what we're going to do once y'all move through the first few slides and come up with some conjectures, we're going to talk about it. I'm going to give you final notes based on what y'all write, address misconceptions and ideas. So, let's take some chances, let's get messy, and let's make some mistakes. That means go! One iPad, by the way. I want y'all looking at it, one iPad together and talking, coming up with a conjecture. Cindy, what was your question? Any what?
Get some paper towels.
Sure. Hey, let's start moving. If you want to just leave your iPad charging somewhere else where someone isn't, then you can do that, and then, someone can hurry up front, right? You know, we're gonna raise everything up. Up on the board, so, we're gonna talk through a couple of things that I need us to see. All right. So, right here, changing A. If I change this A, what's the only feature, well, first off, what are the features of parabola? I need us to hold on to this because I asked one group what the features were. We did not know. What are the 5 features we should be looking at?
Vertex.
Vertex, line of symmetry, x-intercepts, y-intercepts, and concavity, right? Those are my 5 features. You gotta pay attention to that. So when I change A, what's the only feature that does not change at all?
The vertex.
The vertex, right? A is not changing that vertex whatsoever, at least here. And so are x-intercepts changing?
Yes.
Yeah, y-intercepts, are they changing?
Yes.
Oh, and I will point out line of symmetry is not changing either. But here's the thing. The question is, why are those changing? So we studied in last unit, and this kind of addresses what this group up here said. We studied last unit that A that we're multiplying by is what transformation?
A stretch.
A
Oh, dilation.
is a dilation, so it could stretch or it could compress, or it could, what this group up here said, reflect, right? A could reflect. Now, because it's stretching or compressing, yeah, like when I look at it, that's changing the x and y intercepts, isn't it? And at some points I don't even have an x-intercept. But that's not the feature that A is controlling. So let me say that one more time. A does change x and y intercepts, okay? But when I look at A, I don't immediately know what the x-intercepts are or immediately know what the y-intercepts are, okay? So just because it's changing doesn't mean that that's what I automatically know. So yes, A affects the x-intercepts and y-intercepts, but that's not the priority here. What did y'all notice there, Brianna? The parabola is concave down anytime A is
Negative.
negative. Yeah, guys. When A is negative, it's concave down.
Like a frown.
There you go, like a frown. When A is positive, the parabola is
Okay, but like
concave
a
up.
cup.
Okay?
Oh, my.
Okay, so yes, A affects the x-intercepts and y-intercepts, but why? But this is because A dilates and reflects. Okay, so that's why that's happening, but here's the priority. What does A control? A controls the concavity. The parabola is concave down when A is negative, and concave up when A is positive. So, Rihanna, can you add right before the word positive when A is positive? Right? So,
Does A,
soon, go ahead.
does A, it still change the x-intercept, right?
Right, that's what I said right here. Yes, A affects the x-intercepts and it affects the y-intercepts, But remember what I said was, I can't look at A and automatically know what the x-intercepts are and what the y-intercepts are. That A does not tell me that, okay? When I look at the equation, if I give you this equation, do you know what the x-intercepts are just looking at that equation?
No.
No. I know it changes the x-intercepts, but what do you know based on this 3 right here?
It's gonna be up.
What's going to be up? The
Parabola.
parabola is going to be concave up. So what does A control? What does A automatically tell me? It tells me the
Concavity.
concavity. Okay, that's what I'm trying to get us to see is the features. And I want us to connect the features, yes, to these transformations, but I need us to recognize, yeah, it's dilating, it's reflecting, so it's changing the x and y intercepts, but what's the priority? That A controls concavity. And so A says, please do not erase that. I'm going to come circle that so that people can take notes off of that later, okay? So I have a graphic organizer like that for y'all to write notes on, but what I want y'all to do now is I want you to look at the next slide. Oh, by the way, please note, okay, my whole question on slide 3 was, how does the graph of the parabola change when the value of A is positive versus the value of A is negative? That's the priority that I really wanted you to get. So again, what I said, once you have a conjecture, go to the next slide and make sure you can answer that question. The same thing is going to be true here on slide 4. Adjust the values of h and k from the vertex form of a quadratic function and observe what happens to the graph. How do the values of h and k explicitly connect to the graph? Because I want to go ahead and tell you this. The only thing that h and k don't change, any guesses?
The vertex.
X-intercepts.
The concavity. Because what are h and k? What transformation are h and k?
Vertical and
The
horizontal.
y.
Vertical and horizontal translations. So I mean, is it going to affect the x-intercepts?
Yeah. Yeah.
Yes.
Is it going to affect the y-intercepts?
Yes.
Yes. Is it going to affect the line of symmetry?
Yes.
Is it going to affect the vertex?
Yes.
So it's going to affect all those things. The question is, what feature, out of all those features, what feature of the parabola are h and k explicitly connected to? Do I see h and k in the y-intercept? Like, do I see those numbers in the y-intercept? Do I see those numbers in the x-intercept? Do I see those numbers in the vertex? That's what I want you to prioritize, right? So, if you want to erase your board from what A is doing, that's fine, because we're going to prioritize what the aces said and highlight that for when we take notes later. But now I need us coming up with those conjectures. If you already have a conjecture for h and k, reevaluate. And again, when you have a conjecture, move to slide 5 and make sure you can answer that question or those questions. Once you have a conjecture from slide 4, move to slide 5. All right, 3, 2, 1, go!
You say the
Pretty good start. So, once again, just like with before, do H and K, do they affect more than one thing?
yes.
100%, right? We even talked about it before I said go. I told you, hey, the only thing it's not going to affect is the what?
Concave.
Because what does affect concavity?
A.
A is the only thing that affects concavity. Okay, so when I look up here, H and K control the vertex. So right here it says K is the X value and H is the Y value. Do y'all agree? Alright, everybody's in agreement on that language.
I did say that.
And guys, most of y'all did not put that. I need y'all to actually look at the language again.
Wait, but
Wait,
what?
wait.
K equals the H value, H equals the Y value.
We did not write that.
Did I not say that? Did I write that?
You said the H is the what?
X of the vertex.
Is the X of the vertex, and you said K is the Y of the vertex, so we need to investigate. Guys, I need y'all to pay attention to these details, right? When we have differing opinions, we need to investigate. Don't forget, when you write what you have, is it okay to look around the room and see other people's conjectures?
Correct, Thomas.
100% all the time. As long as it's not a test, go for it. Okay? Wait, so are you changing your mind, Ivan?
Wait, hold on. I thought we had to write this.
That's what my point was. Is that's the direct opposite of what you said. You said H is the X,
So
K is the Y, and now you're writing K is the X and
I'm
H is the
dreaming.
Y.
You know what I meant, Mr. Kenny? know what I meant though.
He didn't know what you meant.
Yes, he did.
Okay, so let's
Even when they
investigate
told me.
a little bit more closely. No.
You had that
Okay,
right,
hey
Wait,
guys,
right?
Yeah.
What
So they wrong.
No, that you just raised.
Bro, oh my.
right here.
No, ain't worried about
Hey.
it. What we talking about?
H is what right now? Three, okay? Now, can we all agree that first things first, H and K controls which feature?
Vertex.
The vertex, but we need to be careful. Not just any old X and Y, X and Y value of the vertex, not intercepts, right? And that's where you have to be the most careful. Notice right here, where is 3? That's the X value. K right now is -4, and that is the Y value. So is this statement about K is the X value and H is the Y value, is that correct?
Yes.
No,
Wait, what?
that's not right.
Yes.
Wait, yes, it is right. No, wait, hold on. You made me a mistake. No, that's not right. H is the X, and K is the Y, Mr. Kenny.
Thank you.
No.
Hey guys, I need y'all to look at this and I need you, it's okay to make mistakes, we gotta learn from it,
So
pay
I know-
attention to it though.
I know I wasn't wrong though, Mr. Kenny. So why you had me?
Did I tell you you were wrong?
But you had me second guessing. I was calling you in front of class.
Say some more, boy.
Guys, listen, I know this is atypical, I wanna remind you though, listen, my job as a teacher is initially, not necessarily to tell you the right answer right away, is to make you what?
Learn.
Learn, think.
Learn and
think.
Wait,
Yes,
so the one
my
on-
goal is to make you smarter, but the way we get smarter is by thinking. And I know we're used to teachers asking us questions only if we're what?
Right. Oh, wrong.
Only if we're wrong. Like, oh, you sure it's that? And it's to like guide you into getting to the correct thing. But I'm not that way because I want you to think. I'm gonna ask you yes, I want you to learn. I'm gonna ask you questions whether you got it right or wrong. You gotta investigate, you gotta critically think about things. But right now, once again, H is what? And is that the X value or the Y value of the vertex? That's the X value. K is?
Wow.
A -4.
-4, and that is the Y value of the vertex. Now, that's only 1 point. Let's check a few more. Okay, H is what right now? -3, and that's still the X value, isn't it?
And K
K is 2, that's the Y value of the vertex. Okay, so that sounds like pretty strong evidence to me that H is the X value of the vertex, Y is the, or K is the Y value of the vertex. Now, so I'm going to suggest on this one that I'm going to slightly modify what the king said, but H and K control what?
The vertex.
The vertex.
Oh, God,
See kings. Now, here's what I want to point out. Hey, right here, really quickly. Hey guys, what was the name of this form of the quadratic equation?
Vertex.
It was which form?
Vertex.
And what feature can we most clearly see?
The vertex.
Oh my gosh. It's like they named it. Intentionally. The whole point, hey, y'all, stop talking and listen. The whole point of calling it vertex form is because we see the what? Vertex. I need y'all to be careful though. The most common mistake that students make is they call this K, any guesses?
Dilation.
The Y intercept. Is that the Y intercept though? No, it is part of, it's the Y value of the vertex. They'll say H is the X intercept. Is that the X intercept? No, not X intercept of the vertex. X value of the vertex.
So it changes
So-
from when we did the parent function.
It's connected to that. Hold on. Let's clarify this. I want to make sure that we know this language. X intercept. This is where. What are you talking about? Point where the function intersects the or the x-axis. Guys, you gotta make sure you know that term. That's what an x-intercept is. What's a y-intercept?
Y-intercept is the Y-intercept. The intercept's on the Y-axis.
So point where the function
If that's not, I can.
intersects what?
Y-intercept.
How do you do this?
Intercept,
And it is
the line of symmetry, the vertex, well, Mr. Kenny, intercept, so I'm just saying.
It intersects the y-axis.
I had it.
Okay? In this case, right here, we need to be careful with this. Hey, right here.
I'm trying to close the iPad.
Okay. Right here, guys. It needs to be clear that this, we're talking about the x value and y value of a point. You can say x coordinate and y coordinate of the point as well. But you need to clearly understand and communicate the difference between intercepts and x and y values. Okay? So, you should be through slide 5 now, on to slide 6. Okay, so come up with some conjectures, and we're just going to talk about slides 6 and 7 in a couple minutes. Again, I'm going to update this language, don't erase this, so that you can take notes later. Okay, so let's get to work.
You said do slide number 6.
Slides 6 and 7, please. Just a couple minutes. Oh my gosh. We realize what's the only thing. Now, I want to be careful with our language, okay? So, what a lot of us says, or a lot of us said was H only affects the line of symmetry, and that's not quite right because H also affected the vertex, didn't it?
Yes.
So, how do we need to restate what you said?
So H affects the vertex and the line of symmetry.
Yes, but I was thinking of a slightly different way. How about?
But you didn't ask for the vertex.
You said
I
the
know.
line of symmetry.
Okay.
So H is the only value that affects the line of symmetry. Here's the difference. The way that y'all are stating it is you're saying that H only affects it. What I'm saying is nothing else affects it. Okay? So the way y'all are wording is you're saying H only, Maya, you can go if you need to right now. You're saying is that H only affects the line of symmetry and H doesn't affect anything else. What I'm saying is H is the only thing that affects the line of symmetry. It's closer to that. However, I love what the 9 said. What did I circle over there at the top?
H defines the axis of the line of symmetry.
Okay, the axis of symmetry or line of symmetry. Please note, it's not just that H affects the line of symmetry. H defines the line of symmetry. Okay? H defines the line of symmetry. Please notice right now, what is H? 7. What does every point on the line of symmetry have in common? What's 7? The x value is 7, doesn't it? Okay. What about if I change? Oh, by the way, I would point out then, the equation for this line would just be x equals, any guesses? 7. Because every point has an x value of 7. Okay? So what if I change my h to -2? What does every point on the line of symmetry have now? -2. Right? For the x value. So what would that equation be for this line of symmetry? X equls.
Can you move that to the other side? I want to see if it switch to. Yeah, can you, please.
What do you mean?
Never mind. It didn't change. I thought it
What
would
do you
change to 2.
You talking about the y value?
No, the H value.
Nah, it don't change.
It do change. It changed to 2.
Yeah, but like.
It changed every time you put it as a number, the value.
I don't know. I feel lost.
Penny, right here.
No.
What's my h value?
-2.
Okay. What's the x value of every point on the line of symmetry?
-2.
-2. That's it. When h was 7, way over here, what did every x value on the line of symmetry have in common? X value is 7.
So basically, whatever your h is, that is what your x value is going
Oh, interesting.
to be. All of it.
So the line of symmetry is written as this equation, x is equal to h. Whatever h is, that's what the x is for the line of symmetry. So this right here is a fantastic and near perfect way to describe it. H defines the axis, which the other word for axis is line. H defines the line of symmetry. Quite literally, the equation is x equals h. Please do notice the line of symmetry is a line, so it needs an
Equals.
equal sign. It needs an equation, okay? H defines the line of symmetry. H itself is not the line of symmetry, but it defines it. X is equal to H is my line of symmetry. Yes, sir.
You see what, it's 7 and 6. What is the 6? At the top, the very top, the very first point.
Hold on one second. See, nines, y'all are nines, right? For, what was your question?
7 and 6, the first point on the line of symmetry. What is the 6?
That's just the y value of that point.
So that don't matter on H.
That's my whole point, is that it doesn't matter what the y is. The x is always whatever the h is. That's how we define that line of symmetry. Doesn't matter what y is. Notice I could have put this point right here. That would be the point 7, 4. This would be 7, 7. Notice the y doesn't matter. What matters is that the x value is 7, which is what h is.
You making it difficult the way it is.
Say something.
Hey, Finney. What's that h value over there?
7.
And what does every point on this line have in
7.
common? Not just 7. The what value is 7?
X.
The x value is 7. That's it.
Oh, okay. So the 4 gonna be the y value. The 7 is the H. The 4 is the y value.
Correct.
Exactly.
But that y value doesn't matter for the line symmetry. Just the x value, the h value does. Because it's a vertical line, it goes forever. By the way, I'm sorry, I meant to mention this earlier. Notice h and k control the vertex. There's just a quick note about the idea of transformations. Because remember, this is my what again?
Your Y.
With-
Y is that what you're talking about?
That's
No.
parabola.
It's not just a parabola. This is a special parabola. It's something we studied last week.
Concave up. I don't know.
It's where h is 0, k is 0.
Oh,
Which
the H.
one? That's my parent function. Guys, if h is 0 and k is 0, that's a parent function. Literally, it's on the origin, goes up nicely. Notice if h is 2, it's going to translate to the
No, on the right.
right 2. Notice that's now my vertex. If k is -3, it's going to translate down 3. Notice that, whoops, I went -4. Notice that's the vertex. So the vertex is h comma k because it's literally from the origin been translated to the right or left, up or down. That's why that's happening. That's also why the line of symmetry changes like it does, because a vertical line can only be moved which directions?
Right. Up.
Left and
Right.
right. A vertical line, like, you can't really move it up and down, it would still be a vertical line, but it can move left and it can move right, which is going to cause it to change. So it's only h that changes it left and right. Okay, so here's what I want us to quickly do. So,
Let's get held up.
No.
hold on one second, okay? I'm going to pass out a Frere model, okay? What's the title of this Frere model? Vertex form. There you go.
Yeah, I'm reading upside down, my bad.
I got you, you're good. So there's my vertex form. This information about A, H, and K should go where on this Frere model?
What? What did you just say?
Where should this information about A, H, and
The
K
notes.
go on this? Oh, there's a notes section. Yes, please make sure. Are you serious right now? What do you mean, huh? You ever get on any video again in the middle of my class while I'm teaching? That's right. Is that clear? Put it away. So vertex form, I need you to write notes. Carly, what group are you in? Forwards or back there?
This is it.
Okay. So I need you to write notes about the vertex form of a quadratic function. Specifically, you need to clearly. Why?
This part. This is. I don't know. I think this.
I have
Veronica,
my own paper.
1, 2, 3.
But I'm gonna leave this for her. Cause
Veronica.
this her. Oh, who paid for it?
I need you to write out notes about A, H, and K. Remember the aces have this information about A. H and K for the vertex, we want to look at the kings.
Yeah.
And then for the line of symmetry over here at the nines. Please take your notes. When you're done with your notes, try applying that to, what is it, slide 8. Okay? So once you are done with your notes, try applying this to slide 8. And Brianna, when you're done with those notes, you can run to the restroom quickly. Using all the
in our
information.
In
Oh.
our notes, we just talked about this.
Hey guys, really quickly, let's just look at this first one. Remember, what controls the vertex?
The eighth.
The vertex.
Oh, the H
The H
and the K.
and the K. Remember, we said H is the
H is the X.
It's the X
X value of
the
the.
vertex.
Okay, so be careful because I do want to point out. Hey, Jaw, really quickly. Does anyone see what Jaw was missing? No, write the numbers you just had up there.
Move, Jaw. Can't see what
Come back
Okay. What is Jaw missing with his vertex?
You're gonna go with the
Okay, guys, if you're gonna write a point, you got to make sure that you put parentheses, right? So it's just a notational thing. Now, why in the world is it a positive 3 when it's x minus 3? Why is it a positive 3? Why is x a positive 3 even though it's minus?
Flip the signs because it's inside the.
Remember, with our transformations, we said it's going to be the opposite. So is that going to go to the left or to the right?
To the right.
That's going to go to the right. How far? 3. That's why it's a positive 3. So what's my line of symmetry?
Okay, I can't see the lines.
It's not just 3. You're missing something. That's not a line. That's a number. But what does it say behind Malia? It says what? X equals H. So what do I still need? X equals 3. That's a line of symmetry. What's my concavity? Concave up. How do you know it's concave up?
The positive 4.
A
I
is,
mean,
not positive 4, that's my vertex.
The 2.
A is positive. Remember, A determines concavity. We'll do more practice with this tomorrow. You don't need to worry about doing check your understanding yet, because I want to do the stuff in Desmos first.